seriously, is anyone doing anything with functions and lambdas and serverless things, whether in public cloud, just playing around, touched them, kind of read about them?
Seen them abused.
Yeah, seen them in infinite loops, charging up quite the bill.
It's a great way to pay Amazon to DOS you.
Yeah. Yeah, okay, all right, well, good to know. Then, yeah, go ahead. Great, so you know who we are. One thing you maybe haven't noticed, you may have, but so I have a Twitter handle, whereas Girish may have a PhD. I still have a Twitter handle. So yeah, that's how I go to sleep at night with my. But no, in all seriousness, if we haven't connected, connect up, Twitter or LinkedIn or something. It's I'm just gonna harass Michael one more time. I'm so tickled to get to know some of you guys. I really am. Well, so Alex talked a little bit before about the CNCF, the Cloud Native Computing Foundation. I wear a bunch of hats in the open source community, and one of those that I'm fortunate enough to wear is as a Cloud Native ambassador. That's a distinguishment that's given to folks that maybe hang around long enough and become enough of a nuisance that they just give you that title. But I guess in seriousness, what it means is that I end up participating in the technical oversight committee for this foundation. And actually, let me backtrack and say, so I'm not on the technical oversight committee. I participate quite a bit in this foundation and the working groups. But backing up to say what this foundation is, Alex described it somewhat aptly earlier and succinctly when he said it's the open source foundation that governs the Kubernetes project. That's their flagship project, our flagship project. It is a Linux Foundation organization. The Linux Foundation has many open source organizations. The CNCF has been pretty well skyrocketing. Lots and lots of open source projects looking to come to it as an independent governing body, one that seems to do pretty well by their projects. I think it's been there about 2 years now. We've been reviewing lots of projects, have brought in 16 now. And if we'll do a click. The point of this organization is to help people navigate the cloud native ecosystem. A fair bit of the charter lists out containers as being something of a focus, but that's been expanding here recently into serverless things, into functions. Granted, most serverless implementations, most functions are run inside of a container, but so not all of the world is containers. Much to my dismay, one of the other hats that I wear in the community is as a Docker captain. So again, I'm going to take that story back, Michael. But what we do in there is try to help curate open source projects, try to help wade through the immense number of them that there are, help highlight those, help support them, market them, provide documentation for them, steward them in some respects. They're fairly well independently governed. So if you consider the governance model for Kubernetes, actually Kubernetes unto its own is certainly a whole bunch of talks in one, but just it as an open source project, the velocity and by which it's moving now is, by really any measure, just in the top 3 of projects on GitHub and open source projects to date. It's impressive. If we do a click. These are the member companies. The bigger the icon, the more you pay. The more employees you have, the more you pay. Click. These are the 16 projects that I referred to before. Other than Kubernetes, and now, other than Prometheus, that was the second project, and we're all intimately familiar with Prometheus at this point. There's a rapid influx of others that have come in, and you might notice the 4th one up there, FluentD. Alex talked to us about that one earlier. We've got some other really interesting projects. They really are. The service meshes, in my mind, just tickle my brain. These are all relevant, primarily to us. They're certainly relevant to those that are doing cloud-native things. I'd love to talk to you guys about any of these. If we do a click. and another. One of the artifacts that we produced at the CNCF is a landscape. It's intended to not baffle and confuse, although that's sometimes the reaction that folks have initially. My belief is that it's more helpful than hurtful. It's helpful in that it gives you a structured perspective of the various functions that you'll need to be concerned with if you really are trying to do things cloud native. And then within each of those layers, which projects we've chosen to support and back and help steward forward. There's a lot. There are 3 more that are inbound pretty hot and heavy. One is OPA, Open Policy Agent. It's a project that lets you describe security policies. So OPA has the potential to touch a lot of these layers, because then you can define policies about how you want a lot of these layers to work. Another one is Spiffy. It's for secure identity in a cloud native way. Some of these projects, Spiffy in particular, is sort of inspired by Google again. Another one is Istio. So funny thing about Istio potentially coming in hot into the CNCF is that it would make for really the 3rd service mesh. Today there's Linkerd and Envoy. Envoy really being more of a proxy, a network proxy. But interesting, service meshes interest me. Yeah. Do a double click. All right. Okay. Okay. But there's been enough things to do within the CNCF that the Technical Oversight Committee can't handle it all. And so we've broken out into subgroups. We call these working groups, WGs for short, and we've broken into 4. The first one is the notion that there's 16 projects, and generally as you bring in a project into the CNCF and you donate it, that part of the criteria for bringing one in is part of that criteria is whether or not that project integrates with the rest of the ecosystem, the rest of the 16 projects that are there. To the extent that they do, the working group on the left is a continuous integration working group, and it helps with testing of these projects and the interoperability of these projects, and tries to provide some general support in that regard, build and release, if you will. The networking work group is a work group that SolarWinds has been a part of since its inception. We wear our networking badge proudly there. Really that working group has curated one project, and it's called CNI, Container Network Interface. The tool that Carlo was telling you about earlier interfaces with the Container Network Interface. The Container Network Interface, CNI, it's a specification that says if you're if you're a container orchestrator and you want to run containers and talk to the network, then you would ideally use this spec, and they pretty much all have. reInvent a couple of weeks ago, EKS, the managed version of Kubernetes, was announced. What is that, Elastic Kubernetes Service? Yeah. AWS created an implementation of that spec of CNI and released it into the open source. They didn't necessarily have a choice. It's kind of what you've got to do at this point. There's a storage work group. There's a serverless work group, which is what we're going to talk about today. It's the most active of the work groups. We've also been there from its inception. Oh, all right. I'm going to get my dance steps up. Okay. Anyway, we participate across these. We also are interested in the open tracing spec. We have a distributed tracing capability. You guys saw it in the briefest of moments, App Optics, earlier. But that's of interest to us. And so just this last KubeCon in Austin last week was announced a serverless white paper we've been working on for some time. And granted that the CNCF isn't a standards body that drones on endlessly and argues endlessly about creating a spec that will live on for decades, it still took us a long time to just create a white paper and agree upon what the term serverless means. I'm going to highlight a couple of the areas that there was some points of contention. We're also focused on, this slide's missing a couple of bullets, but we're also focused on open metrics, which is not, actually, if you go click. Oh, yes. Open metrics, which is, it's an effort to create a next-gen SNMP. I expect SNMP is familiar to many of you. And many of you are maybe aware of some of its shortcomings. It is certainly ubiquitous. It's certainly a protocol that we interact with a lot. but maybe it's time for the next version. That specification has a lot, it looks a lot like what Carlo was talking about earlier when he was talking about writing monitor-friendly software and exposing metrics via /metrics HTTP endpoint. Looks pretty similar to that. And then some of these other ones, the Istio and OpenCensus are coming about. That isn't the focus of this talk. I'd love to talk to you about those, but we'll go next. We'll try to pick up the pace here. And those are all hyperlinks, if you didn't believe it. There's SolarWinds. Ooh. Anybody familiar with IPMI? IPMI, the lower level version of SNMP. Okay, count your lucky stars. You do not know IPMI. All right, the serverless working group. Let's dig in a bit about what we do here. Speed race me, Girish, see if I can keep up.
Yes.
Yeah, found it here. Whoa, found it here. Found it here in just a couple of months ago. We ended up getting key players involved. These are the ones here. For some reason, SolarWinds is in orange. Not sure how that happened. But what we attempted to do initially was just come together on like what serverless means, what functions as a service means, what is FaaS compute, what is serverless backends. There's a lot of terms in here. What's the difference between when you're hosting it, or rather when public cloud providers are offering it to you versus when you're maybe hosting an open source FaaS system on-prem? There are different concerns. So the paper talks about a few of the things that I talk about here, but no, that's fine. And so now that we've published that paper, and the links are in there, you should go read it and comment about it. I'm going to tell you a little bit about some of the things that we took from it, but one of the things we're moving on to next is open events. So if you consider functions that are, by and large, event-driven systems, they exchange a lot of messages. They exchange a lot of events. And actually, my manager in the hallway just a moment ago, we were talking about functions, and really he was describing this sort of the highest form of lock-in into a cloud. You're taking your code, literally, you're putting it into, at a function level, into that cloud provider, and you've got this real tendency to kind of start to get locked in there. And so anyway, open events is an effort to create an interoperable messaging or eventing format. All of the prominent public cloud players are partaking in this, even those that you may not come to mind immediately, like Huawei. They're very much so involved. Click. What we did this last week at KubeCon, very late night after the conference was over, maybe after one too many cold ones, we ended up releasing or opening up openevents.io. Go and check it out. It's the start to what would be a spec. Cool. Okay, we also maintain a landscape of these serverless projects. There's quite a few. We try to help understand them. We review them in this working group. I'm giving you the speed version. All right, so let's get into some concrete things here if we can. Functions as a service. This is, for the most part, what people think about when they think about serverless, for the most part. So taking a function and having it execute. There's been some transitional phases about how we got here. Does everybody think that these kind of make sense? These things generally transition together? They don't always go in lockstep, but they sort of moved together. There's sort of this general trend. I'll say that I, for one, don't believe that the world is really, well, yeah, certainly the further you get out to the right, that the world is ever made up of just functions. Like, hey, it isn't. Even A Cloud Guru, a prominent serverless training offering in the space, run their offering as lots in functions, but they don't. They still have to rely on containers and other things. So I was just saying I believe that the world is much more of an and than it is an or. It's really each of these things, not always. A lot of times you're running at least one or two of these. We've seen this transition from the way in which compute is run, generally. And it's sort of transitioned to the extent that people are just focusing on business logic a bit more as they sort of remove themselves from infrastructure concerns. It's good, generally. It can also be bad. It just depends on what you're doing. But that is the general motion. You're generally able to move a bit quicker. I've been told that people as white as me wash out when you stand in front of the slides, all except for my freckles. But things generally execute faster. They spin up faster. Containers spin up faster than VMs. VMs spin up faster than monolithic OSs that are pixie booted onto bare metal machines. And functions spin up pretty darn quick. All save for if it's the first time you're instantiating that particular function, there's actually a little bit of a delay. There's a little bit of a cold start time. Like I was saying before, most serverless systems that run functions generally run a function inside a container. Anyway, there's a little bit of a warm-up time there. Once you've got an instance of that type of function running, that's one of the benefits that's one of the things you would find in the promised land of functions is that you get flexible and precise scaling. So once you have one up and it's warm, scale in, scale out, just based on your workload demand. Another thing that really is at the heart of how most people consider the definition of something that's serverless is that there isn't any cost associated with idle time. So if you don't have a function actively executing, that you as a consumer aren't paying for idle time of the server and the CPUs and the memory. If you're the provider, there's obviously still idle time somewhere, right? So, and then, there's this other notion that as you move further away from the infrastructure, there's just less concern about managing and operating that infrastructure. That becomes an interesting concern that we're going to talk about in a minute. So when do you use functions? When should you go use serverless? When your workload looks like these things, or some of these things. It could be asynchronous. It could be generally independent units of work that can run independently. That's sort of redundant, but smaller jobs. Part of that is that, hey, these independent functions don't need to be all tied together in a larger project. A lot of serverless implementations are heading towards that. Things like step functions, or they're heading towards providing you the ability to really link your functions together and build a larger application using them. If you're running stateless environments, ideally ephemeral, you can store state outside of the function. But again, there's that caveat around cold start time. Do we have another bullet point on there? Yeah. Right. So and if you need to move fast and keep that developer velocity going, you may choose functions. Here's a common use case for when you might want to use a serverless system. Maybe you've got a car and it's got an IoT device that's sending in events about things that are happening on the road. That event needs to be enriched. And maybe you use functions to do that. Maybe they reach out to various systems to get geo data, gather additional vehicle data, maybe get your entitlement information about whether or not your car is still under warranty, or what have you. And so it's a good use case for functions to reach out to these various systems, aggregate that information, and make a decision. So stream analysis is certainly a core use case of IoT. Some other example workloads are things like we'd said, this function implementation, or people that are leveraging functions, generally, functions are an event-driven software architecture paradigm. So things like a database change, that's an event. An IoT sensor outputting a message, that's an event. Processing streams is another good example. ETL jobs that are just batch things. Maybe a chatbot that doesn't need to be sitting there idle, costing you something the entire time, up until the point that somebody messages it, and then it needs to spin up and respond. And so we've got a couple other examples here. Continuous integration pipelines, that's a great example. You're not building 24/7, or at least hopefully you're not. And so to the extent that you're not, you just want to pay for the time that you're actually building. There's another good example is surveillance. You've got video being recorded by video surveillance systems, and that video is coming in. You've got all kinds of things you might need to do on that video. Facial recognition, looking up missing person information, querying other, emergency services, things like that. So, next. Okay, it isn't like, hey, inside the promised land, it's not all golden. There are some pain points. Much like all great conferences, they come to Austin at some point. And I took a snap of this. A friend of mine, the CEO at Serverless Inc., had done a survey and found it very interesting and really sort of relevant to SolarWinds to understand the pain points that developers are experiencing as they move into functions. Some of those being like debugging. It's not easy. Your functions are ephemeral. Moreover, they could be executing in a bunch of different places, and so distributed debugging is a whole nother topic. If you're into that, a friend of mine just founded a company. She has an open source project called Squash, distributed debugging. Pretty cool, check it out. But monitoring too, it's an issue. Like these things come and go, how do you monitor these things? All right, hurry up. So the primary personas here are, interestingly, the developer and the provider, which sort of leaves out the other part of DevOps, the operator. And this has been a kind of a point of contention within this space, is like the term no-op. Well, first of all, the term serverless is like, obviously there's some server running these things somewhere, right? And then the notion that, hey, you don't need operators to help you understand when you're in an infinite loop in your function, or why your function died, or how many are running, or why there's such a delay in your start time, or all these other operational concerns. There still are. They're just elevated a bit from bare metal things. So the landscape right now looks a bit like this. There's the 3 public cloud providers offering their things. I didn't include Huawei Functions Stage, but they have one. These are the prominent open source projects that we reviewed within the working group, the serverless working group in the CNCF. All right, with that, let me switch over to Girish, who's going to take us through one of those, kind of understand this system. So this system is not a public cloud provider's system. This is something you can download and install on-prem.
Hey guys, can you hear me? Yeah, cool. So just like what Lee was presenting, mostly serverless is has been associated with the public cloud. So these are some of the projects which are actually opening it up and helping us deploy to place of our choice. So one of the projects here, we have just chosen a random one, which is a good one, is Nucleo. So hey, yeah, that's the way to go. Yeah, I like the symbol there. Yeah, cool. So what is Nucleo? So it is a serverless platform. Just like what Lee presented, as one of the use cases. So this is a great example, wherein it can actually process real-time events, data processing. It's pretty comprehensive, and it's open and portable and super fast, and it's really cool. Is what I've seen.
Hi.
Hey, cool. Nice. I get to keep another phone. Very nice. And then with respect to the nice thing about this is that they give you multiple options for packaging. It's written in Go, so it's a Go binary is the obvious choice. And the next one is actually Docker container. So depending on the platform you want to run it, you can actually choose a packaging format, so which is very nice. So and then obviously it actually runs on Raspberry Pi, Docker, Kubernetes, GCE. These are some of the options. I know they're actually working on more. Sorry. I know, yeah, well, yeah, I know you guys. Yeah, come on. Okay, so this is the architecture, so I'm not going to take too much time here. So the architecture of this one is pretty interesting in the sense, so it actually supports different types of event sources like HTTP, RabbitMQ, and then database changes, file changes, ETLs. So it actually you can actually configure a variety of triggers. It actually supports a variety of them, and the function processor piece in the middle is actually the main core. So when a function is deployed, it actually spins up a function processor just for that one function. But if you look inside, it actually has event listeners. So for example, so one function can have multiple event listeners too. So and then data binding. So for persisting the state, it gives you an interface so you can plug in your data source and kind of reuse them across. And then at the bottom, is a common tooling, which probably the function would need like the control, logging, monitoring, security, etc. So that's taken care of by the function processor. And on the other side is the the data sources, and of course, like it integrates very well with Prometheus. It's an open source project, so that's an obvious choice for them. So and then at the bottom are some common elements. Like these two are these two here are the interfaces. Like this is a command line interface, and then you have the UI. They have come up with a reasonably good UI. If time permits, I'll try to show it to you. And then the dealer, controller, builder are like very nice components, but they are like common to the platform. So a builder is actually used by these two to build the function and then push it to a repository so that when a function is deployed, it can actually kind of randomly pull. A controller is like the Kube API server. It actually accepts a request, deploys the functions, and things like that. The dealer is an interesting piece, where the dealer does not come into play all the time. It only comes into play when there are multiple streams, parallel processing is needed. When the function really has to scale. So dealer kind of plays that role of managing the errors, managing streams, whether they succeed or not, and so dealer is something which takes care of that. So that's the overall architecture. I'm not going to try to jump too much in. So the function processor has some of the components like I spoke about. So this is the function processor in I would say a more nicer view with some more information on the event sources and the data bindings. And just a note on the event sources here. Let me show another slide. Yeah, so it actually supports 4 types of event sources. Synchronous, of course, like request response. Asynchronous, like message queues, message streams, and the polling streaming. These are the 2 areas where the dealer component comes into play. Kind of needs to manage the streams. So essentially, so these are the different types of event sources Nucleo supports today. So it's pretty nice. And yes, you can actually deploy it anywhere. So that's kind of the goal. Since I have probably another 2 minutes, I'm going to try to squeeze in a demo, but I have to jump onto my mission, and I'm really sorry about that. Not sure if I will be in the view. Okay. Thanks a lot, guys, for following me. So there are, like I said, there are 2 interfaces. One is the UI, and the other one is the command line interface. So I'm going to first try to show a hello world deployment of a function using the user interface, and try to make calls to it from the code. That's kind of what I'm trying to do here. Just give me 1 second. Okay, very nice. Can you guys see this? So this is the UI. So it's very nice. It actually gives you a lot of capabilities, but then since we don't have time, I'm not going to touch on those. So you can actually configure a lot in the user interface. So this is where you code. So this is where you code. This is where you configure, and again, you can actually define the triggers in this interface. So coming back, so I'm just going to pick one sample, which is very nice. So they have a sample function, so it actually loads up here. So you can see the interface is very simple. So you just define a handler, put your code in there, and ta-da, it's ready. So the deployment is again very simple. So you click on deploy. Takes a few seconds, and in the next few seconds, it actually deploys. But just to give you guys an information about the background in the sense where is this running? So I have a Kubernetes instance running on my local using Minikube. So I've just been using that for the demo purposes. And you can see the function has deployed and is available on a particular port. Voila. Okay, that's good. The demo gods are helping. Very good. So I'm going to use the CTL, which is a CLI, the new CTL, which is a CLI for getting the list of functions. And you can see one function has successfully been deployed, which is very nice. So now, and it has a nice interface to invoke the function. Invoke function echo. Voila. Sorry. I think it's the other one. I'm really sorry. Yeah, so you can see so it says that it is executing a function, and that's the URL the CLI made a call to, and it got a response port of 200. It's not, but if you look at the response body, there's nothing, because just showing the function code again, all it does is it actually prints whatever you're sending to it. So we want to be more brave. So let's try this. So I'm going to try a post method and try to see if I can send some data. And that is hello world. I think, come on, we need a hello world, but just a second. I forgot the syntax, so I'm going to ask it. Yeah. I'm sorry. Just a second. I know it's post, and then it's a D with the. Sorry.
The function they must invoke. So
Yeah, I know, but there is actually one more, like, wherein, like, I think you have to send it like a content type, but let's try that. Okay, yeah, it didn't like that, like, so it took the post, but like you can see that the body, like, it didn't go through, so I think it's a B or a capital D or something of that sort. There you go. Voila. So yeah, okay, cool. Yeah, so whatever you send, like, it's actually sending it back. So this is a very simple example, but then in the background, like, it is actually doing quite a bit of things. So just one more thing, kubectl, like, I hope you guys know what kubectl is. Alex is probably the best guy to explain it. Get pods. And you can see the first one there, the echo thing, that's actually the function deployment in this Kubernetes environment. That's everything, guys. I'm not going to bug you more. Have fun.